Welcome to the third lesson in Session 3 on solving systems of equations and inequalities by graphing. Now, whether it's equations or inequalities, a system is one or more equations or inequalities grouped together using common variables. A solution is an ordered pair, an x and a y value, that satisfy all of the equations in the system. We're going to start with systems of equations. When solving a system of equations by graphing, there are three possibilities for solutions. First, you could have two intersecting lines that meet at a single point. That point represents the solution to the system. You could have parallel lines that do not meet. Or third, you could have coinciding lines that lie right on top of each other. To solve a system of equations by graphing, we draw both lines on the same coordinate plane and analyze the result. First, we're going to study intersecting lines. Intersecting lines are lines that cross at a distinct point, and the point of where the two lines intersect is the solution to the system. The solution of a system should always be expressed as an ordered pair. So here's our example. We're given y equals x minus 2 and y equals 4x minus 1. So we graph the first line with a slope of 1 and a y-intercept at negative 2. And we graph our second line with a slope of 4 and a y-intercept of negative 1. Identify where those 2 points intersect. You know they're going to intersect because they have different slopes. They intersect, it looks like, right there at the coordinate 1, 3. And 1, 3 represents the solution. So that means that 1, 3 is a solution to the first and the second equation, making it a solution to the system. Next example, we're going to study what happens when you have parallel lines. Parallel lines never intersect. So they're going to have the same slope and a different y-intercept and will never intersect. A system of equations with lines that are parallel has no solution. So for our example, we've got y equals 2x plus 2 and y equals 2x minus y equals 1. So the first equation has a y-intercept at positive 2 and a slope of 2. In the second equation, we take the opposite of a over b. We have a y-intercept at negative 1 and a slope of 2. Since those two lines will never intersect, there is no single coordinate that will satisfy both of the equations. So our answer is no solution. Next, we're going to study coincident lines. Coincident lines are lines that lie right on top of each other. They're going to have the exact same slope and the same y-intercept, as opposed to parallel lines had the same slope and different y-intercept. So coincident lines constantly intersect, and a system of equations with lines that are coincident have an infinite number of solutions. So here we have 2x plus y equals 2. That's an equation that has a slope of negative 2 and a y-intercept at positive 2. And the second line has the same specs, a slope of negative 2 and a y-intercept at positive 2. Those two lines are constantly intersecting, producing an infinite number of solutions. In our last slide, we're going to study systems of inequalities. A system of inequalities is one or more inequality using the same variables. Solving a system of inequalities requires us to graph both inequalities, or all three if we have more than two, on the same coordinate plane, and we analyze the result. The solution set of the inequality is the area with the overlapping shaded region. So for our example, we have y is less than 2x plus 1, and y is greater than or equal to 2/5 x minus 2. So our first inequality we're going to graph with a dashed line, and it has a slope of 2 and a y-intercept of 1. And now when I substitute the origin as a test point, we get 0 is less than 1, which is true. So we're going to shade the side of the line that contains the test point. In our second inequality, y is greater than or equal to 2/5 x minus 2, we have a y-intercept at negative 2, a slope of positive 2/5, and we have to graph using a solid line. Using the origin as a test point, plugging in the origin, we have 0 is greater than or equal to -2, which is also a true statement. So I shade the side of the line that contains the origin. Now the solution set here is going to be the overlapping shaded region. As you can see by the graph, this region right here represents all of the coordinates that are solutions to the system y is less than 2x plus 1 and y is greater than or equal to 2/5 x minus 2. So that concludes our lesson. In order to earn credit for successfully completing this lesson, you must complete the quiz. Email us if you have any questions. Good luck.